there, we need some basics for doing that. Most of our basics involve being able to evaluate like the sine of pi over 2 or something like that. Having some idea of where an asymptote might be on the graph. So we're just going to go over all of those things. The big thing in calc, in order for all of our calc rules to work, you always have to be in radians, not degrees. So we will assume, unless the problem specifically says you are in degree measures, that we are in radian measure. All the different techniques we use require radians. So let's start with our unit circle. All right, the unit circle we know is a circle. A circle has how many degrees in it? If you go all the way around? 360. These are the common angles that we see in trig. So this would be like 0 degrees, also known as 360 degrees if you go all the way around the circle. Right here would be, oh, sorry, I jumped. 90. Over here would be, and this would be 270 if we did our multiples of 90. The other angles that we use, the common ones, were 30, 45, and 60. Okay. Over here in the second quadrant, remember this is just like the point 0, 0, your graph. To get these, you subtract your reference angle. So this is 180. If I come up 30, so 180 minus 30 is 150. 180 minus 45. 180 minus 60. In the third quadrant, we've gone past 180, so we add our units, or we add our reference angle. So 180 plus 30, 180 plus 45, 180 plus 60, and then this is 180 plus 90, so 270. Here, we do 360 minus these three angles. So 360 minus 30, 360 minus 45, and 360 minus 60. So those are the common angles. Remember, we always go from the x-axis. We never go from the y. So it's the x-axis plus or minus our reference angles. Then we need the radian form. Remember, in radians, 180 degrees is equal to pi radians. So to change degrees into radians, you take your degree measure times pi over 180. So 0 times pi over 180 is still 0. Or 360 times pi over 180. So 360 over 180 is 2, so you would get 2 pi. So 0 and 2 pi represent the starting point. So if you multiply by 30, 30 over 180 is 1/6, so pi over 6. 45 over 180, so that's 1/4, so pi over 4. 60 over 180 is 1/3, so pi over 3. 90 over 180 is 1/2, so pi over 2. Okay, if we jump down here, 180 times pi over 180 is just pi. And then we talked a lot about our patterns with these. Think about your reference angle. We did like 180 minus 30. In radians, you would do pi minus pi over 6. So it's like 6 over 6 minus 1 over 6. So we get 5 pi over 6. Here, this would be like pi minus pi over 4. So 4 over 4 minus 1 over 4 is 3 pi over 4. Pi minus pi over 3. So 3 pi over 3 minus 1 pi over 3 would be 2 pi over 3. Right, here you're adding, so pi plus pi over 6. So 6 over 6 plus 1 over 6 would be 7 pi over 6. Pi plus pi over 4, so 4 over 4 plus 1 over 4 would be 5 pi over 4. 3 over 3 plus 1 over 3 would be 4 pi over 3. Pi plus pi over 2, so 2 over 2 plus 1 over 2 is 3 pi over 2. Just read that. Okay, over here, we're subtracting from 2 pi. So this is like 12 over 6 minus 1 over 6, so 11 pi over 6. 8 over 4 minus 1 over 4, so 7 pi over 4. 6 over 3 minus 1 over 3, so 5 pi over 3. So those are the radiometers, which will be the ones we typically see in calc. Any questions about the degrees or the radians here? The next thing we did was ordered pairs. Remember, in our ordered pairs, x is the cosine, y is the sine. Remember, we did our hand trick to help with that? So our fingers, I need a blank hand on there, I can't. So our fingers were the 0, 30, 45, 60, and 90. The pattern is always square root of something over 2. On this, sine was the top and cosine was the bottom. So if I said 0 degrees, hold in your 0. So cosine is the bottom. There's 4 fingers below the one I folded in. So the square root of 4 is 2 divided by 2 is 1. There are no fingers above the one I folded in. So 0 over 2 is 0. Which makes sense. If this is the point 0, 0, and you go over, that's 1, 0. Right? Think about like if you were just, we were just graphing. This is 1, 0. That's where we're at on our unit circle. Okay. So, pi over 6. So we fold in our 30-degree finger. Cosine is the x. So everybody, use your hand trick to help you. There are 3 fingers below the one I folded in. So that's the square root of 3 over 2. Sine is above. So the square root of 1, which is 1, over 2. Pi over 4. So if I fold in my 45, I have 2 fingers below. So cosine is the square root of 2 over 2. Sine is above. So the square root of 2 over 2. 60. So if I fold in my 60, there's 1 finger below, so square root of 1 is 1 over 2. 3 above, so square root of 3 over 2. And 90, there's no fingers below, so that would be 0. 4 above, square root of 4 is 2, divided by 2 is 1. Which makes sense. If you are right here, that is the point. 0. Okay, so we're just talking about points on this circle. If you can get this part, then you can really get the whole thing. Because these ordered pairs always match up to their referencing. So the pi over 6 and the 5 pi over 6 are the same. The only difference is if you are in the second quadrant, think about if I'm plotting a point, what's going to be true about my x over here? X is negative. So it's these points, but the x is negative. Same for the 1, 0, and negative 1, 0. What's true if you have points in the third quadrant? They're both negative. So the same, the pi over 6 and 7 pi over 6, those match up. It's just both the x and the y are negative. And what about in the fourth quadrant? What's true? Same 3 points. Remember, the denominators tell you which one to use. But in the third quadrant, pi is same. Now, obviously, if we're not doing trig every day, if we're not going to have a whole section on it, you're probably not going to create a unit circle every time you have a question. So that hand trick is really beneficial to you. Okay. Any questions there? I just want to review a little bit more with them. I don't think I even printed this, but you might have room on the back of the formula handout if you, oh, no, you don't. On the bottom of the formula handout, I guess. You can write in some stuff if you need to. So our basic definitions of our trig functions. There are 2 ways we can define them. We can think of them in a triangle. Remember, SOHCAHTOA. Right triangle. This means S for sine, O stands for opposite, H stands for we also had an X, Y, and R definition. So if you think about a triangle, and here's my angle. We can also think of it in terms of X, Y, and R if we needed to. But let's just do the SOHCAHTOA for now. Remember, in this angle, opposite is the side across from it. Hypotenuse is always across from the right angle. Adjacent is the side touching it that is not the hypotenuse. And cosecant is the reciprocal of sine. So it's just if you flip it. Over opposite. What is cosine? Okay, secant is the reciprocal of that, so that would be hypotenuse over adjacent. And what is tangent? Remember TOA, so T-O-A. Cotangent flips it, adjacent over opposite. Those definitions, and remember that a little bit. Let's talk about the graphs of our trig functions, and then we'll actually look at some problems. So remember when we graph them. Not that in calc I'm going to have you drawing the graphs of the trig functions, but sometimes if you have a question and you're trying to figure out something about it, knowing what the graph looks like might jog your memory. So remember on sine, my highest is 1, my lowest is -1. The points on the x-axis were those points on my unit circle. So that was like my 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the points off the x and y axis. Okay, so now we're just evaluating. Sine is 0, so you can look at your unit circle, you can do your hand trick. Sine is the square root of the top over 2, so 0 over 2 is 0. Pi over 2 is 90 degrees, so square root of 4 over 2 is 1. Pi, it's like back to 0, just opposite signs, but the opposite of 0 is still 0. 3 pi over 2 is like pi over 2, except you're in a different quadrant. 3 pi over 2 gave us negative 1. And 2 pi, we are back to our starting point. So remember, this was a curve. Something like that. Sine and cosine are both just waves. The setup of their graphs are very similar. Same points on the x and y axis. All right. What is the cosine of 0? Cosine of pi over 2. And we're getting these basically from our unit circle. Cosine is the x, so 1, 0, negative 1. So pi, we're at negative 1. 3 pi over 2 is 0. 2 pi is back to pi. Something like that. Tangent and cotangent, remember those were the weird ones. We picked different intervals for those because of our asymptotes. Tangent, we went from negative pi over 2 to positive pi over 2, which means these points are pi over 4, negative pi over 4, 0, positive pi over 4. Okay. So tangent is sine over cosine. All right, we did it in terms of opposite and adjacent here, but you could also think of it as sine over cosine. So if you think about at these points, we're asking when our asymptotes happen. Negative pi over 2 is the same thing as 3 pi over 2. If you do sine over cosine, negative 1 divided by 0, that is what? Undefined. We can't do it. So that's an asymptote. At negative pi over 4. So that's the same thing as 7 pi over 4. If you do sine divided by cosine, we just get negative 1. Look at 0. 0 divided by 1 is 0. If you look at pi over 4, radical 2 over 2 divided by radical 2 over 2 is 1. And at pi over 2, you get 1 over 0, so undefined. Remember, this one was curve approaching our asymptotes. Cotangent is similar. We picked this interval so that we would have our asymptotes on the end, and we went from 0 to pi. So this was pi over 4, pi over 2, 3 pi over 4, and pi. Asymptote beginning and end. Okay. So asymptotes, because it was undefined there, if you did pi over 4, radical 2 over 2 divided by radical 2 over 2, it's just cosine over sine, you get 1. At pi over 2, you get 0 divided by 1, which is 0. 3 pi over 4, we get negative 1. So the graph looks like this. Okay. Secant. Secant is the reciprocal of what? Cosine. So we think of it as cosine graph for a minute. And a lot of times when we graph these, we would even draw the cosine graph to start with. We know cosine starts at 1, 0, negative 1, 0, 1. So that's what cosine would look like. So when you do the reciprocal, reciprocal of 1 is still 1. Reciprocal of 0 is undefined, so that's an asymptote. Reciprocal of negative 1 is negative 1. Reciprocal of 0, undefined. Reciprocal of 1 is 1. And when we graph this in trig, we actually test the points to see, but it just turns these graphs away from the x-axis. So the actual secant graph is the green one here. Okay, my yellow was just to illustrate why. But that green is the secant. And finally, cosecant, the reciprocal of sine. So if you think about the sine graph for a moment, sine 0 is 0, sine pi over 2 is 1, 0, negative 1, 0. We do our reciprocal, so reciprocal of 0 is undefined, reciprocal of 1 is 1. Reciprocal of negative 1 is negative 1, and 2 pi is negative. And if you turn your graph away from the axis, it looks like that. What questions do you guys have? The other thing on here, remember in trig we made that flip chart with all those formulas we needed. I put the most important ones on here. We probably won't use most of them. Probably the one that will come up the most often, our most important formula from trig was our sine squared theta plus cosine squared theta equals 1. So the very first formula on that sheet. We might use an occasional sum and difference formula, but that would probably be about it. But I just kind of recapped some of those for you there. All right, do you guys have any questions? Okay. I'm going to do a few problems, and I apologize I did not put these on your slides or on your handout, so you might just want to grab a piece of paper and work these with me. Separate from the back side of that handout that has problems. Just want to refresh some things. So if you have you can work it in the margins if you want, or just a spare sheet of paper. All right. If I give you a degree measure, how do we change it into radians? Good. Multiply by pi over 180. The degrees cancel. I'm trying to simplify this without a calculator, I could drop a 0, 21, 18, both divisible by 3. So we get 7 pi over 6. Negative 122 degrees. We multiply by pi over 180. 5 degrees. All right, what does 122 over 80 reduce to? Mm-hmm. Radians, remember, don't have to have a pi with them, but a lot of times they do. All right, so can we convert into radians? Okay, let's go the opposite way. If I asked to convert a radian measure into a degree measure, how would I do that? Mm-hmm. Still multiply. We want degrees, so those are on top. We want to get rid of the radians, so we put the pi on the bottom. So my pi's drop. 5 goes into 180. 6 times. What do you guys get? If I did 2 pi over 3, multiply by 180 over pi. Drop the pi, so 3 goes into 180. 60 times 2. So remember, if it's degrees, you need to put a degree symbol on it. So we can go back and forth between degrees and radians. Okay. Next thing that was really important and probably will continue to be the most important piece is just being able to evaluate our trig functions. Let's say I give you this. Okay, so what we usually did is ask ourselves quadrants and reference angles. Remember, in quadrant 1 is always pi over something. In quadrant 2, the top was smaller than the bottom because it was less than 180, so this is quadrant 2. My reference angle, if you're in radians, it's just pi over the denominator, pi over 6, or we know that's the same thing as 30 degrees. Remember our trick for positives and negatives? Quadrant 1, they're all positive. In quadrant 2, sine and its reciprocal are positive. Quadrant 3, tangent and its reciprocal cotangent are positive. Quadrant 4, cosine and its reciprocal secant are positive. So in quadrant 2, sine is positive, that means cosine is negative. We have the cosine of 30 degrees. So if you think about your hand trick, cosine is the square root of the bottom over 2, so negative radical 3 over 2. If you look at your unit circle, we look, 5 pi over 6, cosine was the x, we had negative radical 3 over 2. Alright, cosecant of pi, so that's the reciprocal of sine. You can think about your unit circle. Sine was 0. What's the reciprocal of 0? Okay, if you have a negative angle, what did we do? Add 2 pi. We go all the way around the circle. So negative 7 over 4 plus 8 over 4 would just be pi over So that's quadrant 1. We know in quadrant 1 everything is positive. Pi over 4 is like 45 degrees. Sine square root of the top over 2. Radical 2 over 2. Last one. 7 pi over 6. What quadrant is that? 3, because the top is 1 bigger than the bottom. Reference angle is that pi over 6, or 30 degrees, if you prefer to think about that. In quadrant 3, tangent is positive, so that means its reciprocal cotangent is also positive. If we think about 30 degrees, tangent is radical 1 over radical 3. So cotangent would flip it, be radical 3 over radical 1, or just radical 3. Any questions on that? Last couple. Let's practice solving some equations. Solving an equation with a trig function is starts off just like any other equation. You have to get the variable by itself. So I have to get my cosine by itself. So if we add over the 1, how do we get rid of a square? And if you add a square root, you also need. So I'm asking you every time on the unit circle, cosine is equal to positive or negative 1. You're welcome to look at your unit circle. Cosine is x. When is cosine 1? 0. When is it negative 1? Yeah, 180 in degrees. I didn't specify. Let's just do radians. So that's 0 radians or pi radians. If I say all possible, we know on that circle, every time I go all the way around, I'm going to get to that point again, right? So what do I add to this to show I can go around again? 2 pi. And we can go as many times as we want, so we get plus 2 pi k with that. What does k have to be? Yes, any integer. Remember, that was my shorthand, or you could say it in words. Because it could be like a positive 2 or a negative 2. It just can't be a half. There are certainly more concise ways of writing this. 0 plus 2 pi k is just 2 pi k. But I want to make sure we understand the point. The only reason I had to put the plus 2 pi is because I said all possible solutions, not just between 0 and 2 pi. Alright, this one, if I want to get my tangent by itself, I can subtract my radical 3. And divide. In which quadrants is tangent negative? It's in quadrant 1, they're all positive. In quadrant 3, tangent is positive. Alright, reference angle. When is tangent radical 3 over 3? So think about our hand trick. Tangent of 0 would be 0. Tangent of 30, radical 1 over radical 3, which is radical 3 over 3. So it's 30 degrees or pi over 6. So pi over 6 in quadrant 2 and in quadrant 4. Oh, I didn't. I said all possible, didn't I? What would I have to do if I wanted all possible? Where k's? I want to solve this, we have to get sine by itself. I have a sine squared and a sine. Take out a sine. All right, then what do we do? Alright, I only asked for 0 to 2 pi, so I don't have to put the plus 2 pi k. When is sine 0 on my unit circle? Okay, if sine is negative, which quadrant is sine negative? Reference angle. When is sine 1/2? 30 degrees, which is pi over 6. So pi over 6 in quadrant 3, and the top is 1 more, so 7 pi over 6. Quadrant 4, double minus 1 be 11 pi over 6. What questions do you guys have? I'm stopping here.